students. In this video, I am going to explain about the different phases of a compiler. Now, first of all, what is a compiler? Compiler is a software that converts the program written in high-level language into machine language program. So, what is a high-level language program? Whatever we write in English, like Java program, C program, C++ program, .NET program, all these programs are high-level language programs. So, machine cannot understand these programs. So, this should be converted to zeros and ones for the machine to understand. So, this translation process is done by the compiler. So there are some compilers which converts high-level language program into assembly language program, and further the assembler converts the assembly language program into machine language program. So machine language program is nothing; it's written in zeros and ones. Assembly language program is nothing; it is close to machine language program, but it is in understandable format. Will be in English characters, that is assembly language program. So this compiler on the whole, in general, it converts the high level language program into the machine language program. So we have a compiler, C compiler, Java compiler, .NET compiler. So like this we have the compilers. So the languages before execution, whatever program we write in high level language, it should be converted to machine language program, then only it will be executed. Okay, in some languages they use interpreters like Python, MATLAB, all those languages. But some languages they use compiler. So what is the difference between compiler and interpreter? Means compiler, it converts the entire source program into machine language program, then the execution takes place. But the interpreter, line by line, it converts to machine language and then gets executed, and then only goes to the next line, second line. After conversion, then the interpretation takes place, and then it executes, then goes to the third line. So like this, so if there are error in the third line, there itself it stays there itself, it does not goes to the next line, does not proceed, stop there itself. So that is the interpreter. But the compiler, it will convert the entire program into machine language program for which is ready for execution. If there is no error, then we can execute it. If there are errors, it will be listed out. The compiler lists out all the errors, then we have to correct all those errors, and then again compile, and then only we can execute. So this compilation process cannot be done in a single step. So it is partitioned into various phases. So these are the phases of the compiler: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. And there are also two other data structures like symbol table manager, and also there is a error handler which interacts with all these phases. Now we will see the phases one by one. First is the lexical analyzer. So lexical analyzer, what it does means, it takes a statement, it scans character by character, and it groups the logically related characters together into a token, and it identifies the tokens. Okay, so what is this token in English language? Also we say, so for example, there is a statement in English language like I am a teacher. So here the meaningful words, I is a token, am is a token, a is a token, teacher is a token. There are 4 tokens. So these are the token meaningful words in the dictionary, found in the dictionary. So these are the tokens. Likewise, the meaningful words we say, okay, they are the tokens which gives meaning to the language. That all can be classified as tokens. There are different types of tokens like identifier token, constant, operators, etc. Okay, so these tokens are identified in a statement. So this is the main function of the lexical analyzer. Now look at this example: position equal to initial plus rate star 60. So here what are the meaningful words? Position is the identifier token, equal to is the operator token, again initial is the identifier token, plus is the operator token, rate is the, again it is the identifier token, star is the operator token, 60 is the constant token. So there are totally 7 tokens. Okay, so identification of token is the main purpose of lexical analysis. Next is the syntax analysis. Now this identified tokens, the stream of tokens are passed to the next phase, which is called the syntax analysis. The syntax analysis, what it does means it's grouped together these related tokens to form a syntactic structure. And then the syntactic structure can be represented by a parse tree. Only if there is no error, then we will be able to construct the parse tree. If there is an error, we cannot construct the parse tree. So here we check whether there is any syntax error in the by grouping the tokens together and forming the syntactic structure. We find out whether we are able to form the syntactic structure. Okay, if there is no syntax, they are not able to find it, then it will be the syntax error. Syntax error. So mainly this phase is used to identify identify the syntax of the particular statement. Now here we have the position equal to initial plus rate star 60. So these all these tokens are grouped together into a single statement and the syntactic structure is formed. That is the parse tree is formed. So in the when you construct a parse tree, if you have A plus B, here plus is the operator, A and B are the operands. So plus is put in the root and A, B are put as the branches. Okay, like this here, position equal to initial plus rate star 60. So the operators are put in the root and the branches, the child nodes are their operands. So in that way, we have constructed this parse tree and there is no error. So we were able to construct a parse tree. We have constructed. Now we go to the next phase, that is the intermediate code generator. Now after we found out there is no syntax error, we construct into 3 address code statements. So if the statement, the position equal to we had the position equal to initial plus rate star 60. This high level language code statement is again translated into 3 address code statements. Okay, so how it is converted means first real we are converting into the real that is the 60 value we are converted to real value, that is we are assigning to temp1, then temp equal to id3 star temp1. Okay, so here id3 is nothing, it is the rate. So id1 is position, id2 is initial, id3 is rate. So id3 star temp1, temp1 is nothing, 60.0. This multiplied and it is stored in temp2. Now this temp2 is added with id2. id2 is nothing, it is the initial, that is assigned to temp3. Now id1, that is a position, position equal to temp3. Likewise it is split up into statements like 3 address code statements. So maximum there will be only 3 addresses. Like here the statement 1 we have only 1 address temp1. In the second statement we have 3 addresses, temp2, id3, temp1. This is how, so more than 3 address we cannot have in a statement. So in this way we have to translate the statement into 3 address code statements. Okay, so these are identified as the lexical analysis, the syntax analysis and intermediate code generation. These are collectively called front end, and then we have the back end also. So symbol table is used to store all the identifiers, the data types and the values stored in the identifiers. These are stored in the symbol table. Now the code optimization. Code optimization is again what we are doing means we are optimizing the code we have generated in the previous phase. So optimization means we have to speed up the operation but the memory should be also, size should be reduced. So in that way we optimize, we have to optimize. So there we had 4 statements, we have converted into only 2 statements. Directly there we have applied the operation conversion of real 60 converting to real. So that we have applied, but here directly 60.0 we have did that 60.0. Temp1 equal to id3 star 60.0, id1 equal to id2 plus temp1. So the same result we will be getting. So 4 statements we had, we have converted into 2 statements. So here memory size is also reduced, operation will be also fast when compared to the previous one. Now code generation. Now this statement is converted to the machine language code. In this case we are converting to assembly language code. So assembly language code is somewhat closer to machine language code. In this assembly language code we will be mentioning the registers, register names, and also the statements, move statement, everything in detailed manner we will be writing. Okay, we will be designing the memory locations, which memory location we have to store, which registers we have to store and do the computations, and the result where we have to store. All these details we have to mention in the assembly language code. So in that way what we are doing means id3, first we are moving the id3 to r2, then we are moving the multiplying R2 with 60.0. That is R2 is nothing, it is a rate star 60.0. Now the answer will be stored in R2. Now what we are doing, moving R1 id2 to R1. id2 is nothing, it is the initial. So initial variable, the value in initial variable is stored to R1. Now add R2 and R1. Already on R1 what is there? Rate star 60 is there. In R2 initial is there. So initial plus rate star 60. The result will be in R1. Now moving R1 to ID1. ID1 is nothing, it is a position. So position is equal to the value. So the answer result is in R1, that is moved to the identifier R1. So this is the meaning of this assembly language code. So like this we have completed all the phases. Finally we have arrived at the assembly language code. Now we have symbol table. So this symbol table will be used in all the phases to store all the identifiers and also the data types used in the program. The error handler, if they come across any errors in any of the phases, that will be identified and displayed to the user. That is the use of the error handler. In some cases, the recovery strategies also is applied. Okay. So in this video, we have seen about the compiler. What is a compiler? What are the different phases of the compiler? So on the whole, the compiler, when we give the source program as an input, the source program in high level language as an input, we get the assembly language code as an output. Okay, so compiler is a software that converts high level language program into machine language program. Thank you.